Welcome everyone. Let's begin our lesson for today by going over the learning goals and success criteria. First, what are we learning? We're learning how to formulate logical mathematical arguments in order to prove mathematical principles and to prove the closure of rational numbers under mathematical operations. How are we learning it? Through the rational closure proofs review notes and the rational closure proofs review assignment. When can we use this information? To organize thoughts and ideas about any topic in order to provide a valid argument for your thoughts, beliefs, and ideas. How do we know we learned it? By getting a score of 4 on the rational closure proofs review assignment. Now let's take a look at our agenda for today. We will begin by going over our learning goals and success criteria. While we do that, you'll fill out your Get It Started. Once you've completed your Get It Started, we'll go over it together and answer any questions that you may have. After that, we'll go over the rational closure proofs review notes, and then I'll give you time to complete the rational closure proofs review assignment that is on Desmos. Once you've completed the assignment, we'll go over it together and answer any questions that you may have. At the end of class, we'll go back over our learning goals and success criteria while you fill out your before you go. Your only homework for tonight is to complete any incomplete assignments that you may have. Let's take a look at the rational closure proofs review notes. Our notes begin with the learning goals and success criteria. Now, what is a rational number? A rational number is any positive or negative number that can be written as a fraction. Notice that a fraction is considered to have both a numerator and denominator that are integers. So an example of this would be 2 over 3. It can't be 2.5 over 3 or pi over 3. Those would not be considered rational numbers. So it's got to have an integer in the numerator and an integer in the denominator. That's the definition of a rational number. Now, what is a proof? A proof is a logical argument that shows that a statement is true. So you'll be given a statement, and you will have to decide if that statement is true or not. And if it's true, you have to be able to prove that the statement is true. And to do this, we'll be using a 2-column proof. So on the left side, we have our statement. And on the right side, we have our reasons. The statement is the claim that we are making. It should always begin with whatever information is given. Then we will continue into the information that we decide based on the given information. So, statement is basically what we know. The reason is a mathematical justification for the claim. These have to be proven mathematical theorems or definitions that we know to be true. So we can't just say it's true because we say it is, or because we think it is, or something like that. It has to be a proven theorem or definition that allows us to state that that is the case. So what does it look like? This is an example of a 2-column proof. So we have our statements over here. A over B plus C over D are rational numbers. That's a given information. So always we'll begin with our given information, which means the information that they actually tell us. From there, we start coming up with other things. So we can say that this is A over AD over BD plus BC over BD. How do we know that? Well, all we did there was to get from here to here, we found common denominators. And that's the definition of common denominators, right? That's something that we know to be true. So we use definition of common denominators to be able to add these two rational numbers, even though they don't have common denominators already. After that, we have that AD, BC, BD are all integers. So this is an integer, and the denominator is an integer. And the reason we know that is because we've already proven during our last unit that integers are closed under multiplication. So we know that because they're closed under multiplication, then A times D, as long as these are both integers, the result will still be an integer. Then we can go ahead and group these. We leave the denominator as BD, and then we add AD plus BC. And that's just the addition property of fractions. We know that when we do this, we just add those two numerators together and leave the denominator as it is. Now we know that AD plus BC is an integer. This plus this will be an integer. And we know that because we know that this number and this number will be an integer because of the addition property of fractions. We know that this number and this number will be an integer because we know that integers are closed under addition. So if I add any two integers together, I get another integer. So now if this is an integer up here, the result of up here is an integer, and the result of down here is an integer, then it becomes a rational number. So that is just the definition of a rational number, because the definition of a rational number, as we stated earlier, was that the numerator is an integer, the denominator is an integer. So notice that every statement has a reason, and every reason is a proven mathematical concept that we've already learned. It's not something that we haven't learned yet. It's everything in there is stuff that we've already learned. And notice that we started with the given information and worked through to the conclusion. So we're going to actually do this proof now. So we're given that two rational numbers, and we're expected to prove that rational numbers are closed under addition. So this should always be how it starts. A over B plus C over D are rational numbers. It should always start that way. Now, the operation may change. If we're doing subtraction, then this would be A over B minus C over D. If we're doing multiplication, it would be A over B times C over D. But no matter what, we start with this, and that's given information, right? We're told that they're rational numbers, so that's given. And all we did was break it down and write them as A over B and C over D. Now we should note that A, B, C, and D are all integers, and we know that because of the definition of a rational number, right? Because these are rational numbers, that means that each of these have to be integers. Now, from that, we need to decide how can we actually add these together? How can we add A over B plus C over D? Well, we should notice that they don't have common denominators. This one's B, this one's D, so we need to create common denominators. So in order to do that, we need to multiply both the top and bottom here by D and top and bottom here by B. And we should end up with A over D times B over D. And we should end up with AD over BD plus BC over BD. And all we did there was find the common denominator. So that's definition of common denominators. Now from that, we need to be able to recognize that AD, BD, and BC are all integers. And how do we know that they're integers? Well, because we know that integers are closed under multiplication. So that's our reason. So we know that this is an integer, this is an integer, and this is an integer. So far, even though we changed these and have common denominators, we haven't changed the fact that we have rational numbers. We're still adding two rational numbers together. Now, we're going to go ahead and combine the numerators, just like we would with addition of fractions. So we have AD plus BC, and the denominator stays the same, which is BD. And that's just the addition property of fractions, right? We just add, the addition property of fractions says we add the numerators and leave the denominator as is. Now, the question is AD plus BC an integer? Well, it is an integer, and we know that because of integer closure under addition. So anytime we add two integers together, we know that we end up with another integer. So we already stated that this was an integer and this was an integer. We add them together, we get another integer. So that means that this part up here and this part down here are both integers, which means that it's a rational number. And the reason for that is just definition of a rational number. Remember, a rational number definition says that the numerator is an integer, the denominator is an integer. We proved that this is an integer and this is an integer, therefore it is a rational number. Now let's look at an example for multiplication. So we're given that we have two rational numbers, and we're expected to prove that rational numbers are closed under multiplication. So we're going to start with A over B times C over D, and we're going to state that those are rational numbers, and that's given to us. Now we should note that A, B, C, and D are integers, and we know that they're integers because we're given that these were rational numbers. So if they're, by definition of rational numbers, that means that the numerator and denominators each have to be integers. So our reason for that would be the definition of a rational number. So now we're going to go ahead and multiply A over B times C over D. And that's given, right? That's what we're told to do, is multiply them. Now from that, we're going to go ahead and multiply. We know that by definition, we're going to multiply directly across. So we get A times C and B times D. And that's just the multiplication property of fractions. Now, we need to determine, are AC and BD, are those integers? Well, we're multiplying an integer times an integer, so we know that by the integer closure, we know that when we multiply two integers together, we always get another integer. So, and that holds true for both the numerator and denominator. So therefore, AC and BD are integers because of integer closure under multiplication. Now from that, we can say that AC over BD is a rational number because of the definition of rational numbers. Because if this is an integer and this is an integer, then the result is a rational number. Here are some theorems and definitions that you'll need to use for your assignment. Given, definition of common denominators, the addition property of fractions, subtraction property of fractions, multiplication property of fractions, the reciprocal property of division, integer closure under addition, integer closure under subtraction, integer closure under multiplication, and definition of a rational number. So everything that you need for your proofs are on this slide. Let's talk now about how to sign in to Desmos to complete your work. So what we're going to do is you're going to click on the link to go to the assignment, and it should take you to a page that looks kind of like this. And right here where it says sign in with Google, we're going to click there. And it's going to pop up with our email accounts. You're going to click on your school email account, and it should already have you logged in because you should have already been logged in using Google Classroom. From there, I'm just going to click start the activity, and it will take me into the assignment and allow me to begin. So that's how you will log in to Desmos using Google. Let's take a look now at the rational closure proofs review assignment. Our assignment begins with the learning goals and success criteria. If we scroll down, there's a link here to take us to the Desmos activity. If we click on that link, it should take us to a page that looks like this. We'll go ahead and click start the activity. Our learning goals and success criteria are here as well. We'll go ahead and click next. And it asks us to fill in the proof. Now, some of the parts are filled in for you, some of it is not. So we're going to fill in what's given. It says prove that rational numbers are closed under addition. So what we know are we're starting with rational numbers. So we know that A over B and C over D are rational. Okay, that's our starting point. That's given to us. Now, from that, we're go to here where it says AD over BD plus BC over BD. And how did we get there? Well, we started by adding these together. But now they didn't have common denominators, so this just showed that we can give them common denominators. So our reason for that is definition of common denominators. Then we'll continue on to the proof. Now this proof is actually in your notes, so you can kind of refer to that. So you'll do it for addition. Then you'll do it again for subtraction. Then multiplication, and lastly, you'll do it for division excluding 0. So you'll go ahead and fill all this in, all the blank spots, you'll fill those in, and then at the end, you'll go back to your Google form and click next. This will send you to your before you go. Go ahead and submit your before you go, and then submit your work on Google Classroom.